Today's lesson is on sketching graphs of functions and their derivatives. We have been doing this a little bit throughout Unit 4 and 5, just kind of discussing the relationship between f of x and then the derivative of f of x and the second derivative even. But today's lesson is focusing on actually sketching these graphs. So for the first two examples, we're going to start with an f of x graph, and then we'll sketch the f prime of x. Okay, so starting with f of x. So I just kind of place some random points on here, and then I'm going to connect them. So we're going to go up and down, up and down. So this is actually mimicking a fourth degree polynomial graph. So when we're sketching these, we're not going to be super specific. We're just going to kind of get the main idea. So a derivative graph is also called a slope graph. So let's think about the slope of f of x. Here it is increasing, here it's 0, decreasing, 0, increasing, 0, decreasing. Okay, so what I like to do first is to sketch a derivative graph is wherever f of x has a slope 0, so on the relative min and max, I'm going to put a dot at 0. Now think about left and right of that 0 point that we just plotted. So this one, so it's increasing on the left, it's decreasing on the right. So the derivative graph has to be positive on the left and negative on the right. Okay, so I'm just going to make a sketch. So it's positive where it's increasing, and then it hits 0, and then it's negative while it's decreasing, and then it has to come back up because the second we hit this 0, it's now increasing. And then as soon as it hits the other 0, it's got to be negative. So notice how we started with what would be a quartic polynomial, and the derivative is a cubic polynomial, which makes sense thinking about the power rule. Okay, so the next graph is, you can almost think of it as like a piecewise defined function that's going to have 3 different linear functions. So this first one, it's about slope 2, and then it switches, and now it's slope -5, and then slope 1/4. Okay, so slope of a linear function, so these are like 3 different linear functions pieced together. The derivative of a linear function is just a constant. So if you're looking at this first piece, the slope is always at 2. So that means from this x value to this x value, the slope is always 2. And then from, let's see, this x value here to here, the slope is -5. So 1, 2, 3, 4, 5. And then that last piece, the slope is always a positive 1/4. Okay, so now we're going to go backwards. So now I will give you a derivative graph, and we'll have to go backwards and sketch the original function. Okay, so the derivative graph is going to be a parabola. So what does that mean? On the derivative graph, we have to look at, okay, so where is it 0? So that would be your relative, like your critical points on the original function. And then where it's positive, your original function needs to be increasing. Where it's negative, your original function would be decreasing, and then here's positive again. So, all right, so at this x value, where the derivative is 0, that needs to be a relative max. So, and it has to be relative max because on the left of it, it needs to be increasing. And then where this x value is, we need a relative min because the left of it is decreasing. and then it will be increasing. And this makes sense because original f of x is cubic, and then the derivative is quadratic. And now our last example, starting with the derivative graph, sketching the original. Okay, so here is the derivative graph. You could think of this as kind of another piecewise function. So notice how the entire derivative graph is positive. So that means that f of x has to be increasing on its entire domain. But even though it's increasing, there's still that 0, meaning at some point there is a slope of 0. Notice here how that's a constant, so that last piece will be a linear function. And here where we have like the linear function, we're going to have a curve. Okay, so we're just kind of sketching a graph of what we think it might look like. So it has to be increasing the whole time. At some point it would have to be 0. And then at some point at this x value here, we have to all of a sudden have a linear line with slope 2 because that's a constant at 2. So up 2 over 1, up 2 over 1. So there is our sketch. So in this lesson, we're not being super specific on what the actual functions are. We're just trying to sketch a possible graph that could represent either going from f of x to f prime or starting with f prime and going to f of x. So good luck with your lesson.